Okay, so now we need a little more review, and that's again chapter 14 of class, this is class 10, which I started in the first place, but then I had to go back to class 9 and do a couple of things over there as well. So now basically in the previous video we studied the classification of data into ungrouped and grouped frequency distributions, which now hopefully you understand the meaning of. You have also learned to represent data pictorially. We saw basically histograms, we saw pie charts and things like that. There is also something called the bar graph. We saw the bar graph as well. And there is something also called the frequency polygon that is not, I believe, not that important here. So in fact you went a step further by studying certain numerical representatives of the ungrouped data, also called measures of central tendency. So we studied basically the mean, the median, the mode, and we are going to study the mean, the median, the mode in this video. So in this video what we are going to do, we are going to extend the study of these three measures, meaning the mean, the median, and the mode, from ungrouped data to that of grouped data. So basically what we want to do here in this video exactly is that there are three measures of central tendency. So there are three measures of central tendency. There are three measures of central tendency, namely the mean, the median, and there is also the mode. Now, it's possible to calculate the mean, the median, the mode for basically for group data, and also for ungrouped data. Now for ungrouped data, it's easy to calculate the mean, the mode, and the median. For example, if you have a set of observations, let's say you have, for example, 2, 5, 6, 7, 8, 9, 5, for example, 3, 2, 1, and 10. We have all of this data over here. This is just a bunch of observations, ungrouped data, and for example, if you want to calculate the mean of this data, it's simply the average of the data that you have, meaning that you have 2, 5, 6, 7, 8, 9, 5, 3, 2, 1, 10. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 observations. So here your n is equal to 11. And so the mean of this data is equal to the sum of all of the observations, meaning that 2 plus 5 plus 6 plus all the way up to 10 divided by 11, which is, well, it gives you some number as the mean of your data. So that's basically, which is the average of all of these numbers. And you already must know about this. Now the median of the data is basically the value of the value of the observation that comes exactly in the middle of your observations if you basically sort your observations basically in an ascending order, for example. Meaning that if you write, for example, your observations as 1, 2, 2, for example, 1, 2, 2, 1, 2, 2, for example, 3, and then you have 5, 6, 7. So you have 5, 5, 5, 6, 7, 5, 5, 6, 7, and then you have 8, 9, 10. 8, 9, and 10. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 observations. And then we said that since your n is equal to 11, the number of observations is an odd number, then suppose that, for example, you have x, y, and z. So since your observation is an odd number, for example, the number of observations is an odd number, for example 3 in this case, so then you would have n divided by 2, which is 3 divided by 2. But then I need the second, so 3 minus 1, I think, divided by 2, that would be right. So 3, no. N divided by 2, n plus 1 divided by 2, 4 divided by 3, 4 divided by 2 is equal to 2. And if I have 5, x, y, z, a, and b, for example, now the number of observations is 5. Now 5 plus 1 divided by 2 is 3. So it's n plus 1 divided by 2, right? So we said that the observation that comes exactly in the middle of these observations, which is given by, in the case of odd number of observations, is given by n plus 1 divided by 2th observation is your median. It is your median. And so of course intuitively you would go basically 5 plus 5 is equal to 10, so you would pick 5 numbers here and 5 numbers here, and this number comes exactly in the middle of all of the observations. So you would have basically 11 plus 1 is equal to 12. 12 divided by 2 is equal to the 6th observation here. 1, 2, 3, 4, 5. The 6th observation, this is your median, the median of your data. Now, if you want to have a practical example for the median of the data, I don't know a good example right now. Probably the age of a couple of people, a bunch of people, but let's get past this. I want to just give you, hopefully, necessarily only the theory here. So that is the median and how you calculate it in case of ungrouped data. Now, in case that, for example, suppose that your data looks something like this. For example, you have 1, 2, 2, 3, 5, 5, for example, 6, 7, 8, 9, 10, and add an 11 here. So now the number of the data, the observations that I have is, in this case, is 12. Now my n is equal to 12, right? So now, since my n is equal to 12, I can pick, for example, 6 numbers over here, and I can pick 6 numbers over here, and there remains no number between all of these numbers, so there is no median. So what I need to do is that I need to pick 5 numbers there and 5 numbers there, and then there remains 2 numbers as the median of the 2 numbers of the median of the observations. So the way that you can calculate the median of these of all of these observations, since your n is an even number, then you can simply go with n divided by 2, n divided by 2th observation, and also by n divided by 2 plus 1th observation. Meaning that if n is equal to 12, 12 divided by 2 is equal to the 6th observation, which is 1, 2, 3, 4, 5, 6, and the 7th observation, which is the next one after the 6th observation. So that is basically how you find the median of a set of observations, ungrouped data. Now, there is one more measure of central tendency related to data, which is called the mode of the data, right? So the mode of the data is basically, you can see that 1 has occurred 1 time here, 2 2 times, 3 1 times, 3 1 time, 5 2 times, and then that's it. So now suppose that the data that I have was basically something like this. Suppose that the data that I have was, I don't know, something like this, for example, 3 5 6, and there was another 2, for example, over here. There was another 2 over here. So now 2 has occurred 3 times here, 6 has occurred 2 times here, and let's say that, for example, 11 has also occurred. Let's say that 11 has also occurred, for example, 11 has also occurred 2 times here. So what this means is that, you know, of course there was something that I forgot to say over here, but we will get to that later. Now you can see that 2 has occurred 3 times here. Now the observation that has occurred, the highest number of times in your in all of your observations is called the mode of your data. So over here the mode of your data is equal to 3, because it's 2, because 2 is the observation that has occurred 3 times, 6 is the observation that has occurred 2 times, 11 is the observation that has occurred 2 times, and all the other observations have occurred only once. The other observation the only observation that has occurred the largest number of times is basically 2 here, whose frequency is 3. So then your mode is equal to 2. Your mode again is the observation that has happened or occurred the highest number of times in all of your observations, and that's how you calculate it in the case of ungrouped data. Now, of course, you know that basically when it comes to when you're dealing with ungrouped data, it's just everything is manual, and there is nothing, and you don't really need any formulas or anything like that, because at most you're dealing with, I don't know, for example, 10 observations, 20 observations, 30 observations, not more than that. But then when the number of observations gets higher than that, or larger than that, then of course you have to group your data, otherwise you wouldn't be able to work on them. And then when it comes to grouped data, meaning that then you, for example, when you have some example like the 60 numbers that we wrote in the previous video, and then we we defined all of those class intervals. For example, we said 0 to 10, and then 10 to 20, and then 20 to 30, and so on and so forth, which was called a grouped frequency distribution table. Okay, so then when it comes to group data, then of course you cannot just keep on counting things. That's not possible. there we need to develop some formulas which is basically the very foundations of statistics, and that's what we want to do in this video, or probably even in the next video, because I don't think we could talk about everything here in just 1 hour. There is a couple of things that need to be discussed. So let's see how we can take care of them. Okay, so now let's see how we can find the mean of, for example, the mean of group data. Let's see how we can find the mean of group data. Okay, so basically the mean or the average of observations, as we know, is the sum of the values of all the observations divided by the total number of observations. So we already know that the mean or average of observations is equal to basically the sum of the values of all the observations, the sum of the values of all the observations divided by the total number of observations. Divided by the total number of observations. And again, what that means is that, for example, if you have 2, 3, 4, 5, and 6 as basically 5 observations that you might have, then the mean of those observations is going to be equal to 2 plus 3 plus 4 plus 5 plus 6 divided by 5. The number of those observations, 1, 2, 3, 4, 5. Now, if I call these observations x1, x2, x3, x4, all the way up to x sub n, and of course with respective frequencies, respective frequencies f1, f2, f3, f4, all the way up to f of n, meaning that, for example, let's say that in the previous video I showed you a couple of examples. For example, let's say that you have some observations. For example, let's say that you have some observations like 1, 2, 3, 4, and 5, and these are your observations, or x sub I, and then the number of those observations, or the number of times that these observations have occurred. If you denote that by the frequency of those observations, called f of I, then that would be, for example, you would call them, for example, f of 1, f of 2, f of 3, f of 4, f of 5. If you call these, for example, x of 1, x of 2, x of 3, x of 4, and x of 5. Of course, these could have any other values. For example, this could be 11, 12, 13, 14, and 15, for example. But you need to understand the notation. The notation basically refers to the value of your observations, and the frequency refers to basically the number of times that particular observation has occurred. So that means, what that means is that if the observation x1 has the frequency f1, that means that the observation x1, for example, 5, and if f1 is 4, that means that in your data you had 5 4 times. If your x1 is equal to 4 and if your f1 is equal to 3, that means that 4 has occurred in your observations 3 times, and so on and so forth. So then, going back to the definition, we said that if x1, x2, x3, x4 all the way up to x of n are observations, and these are the respective frequencies. These are the respective frequencies of those observations. Then that means that basically observation x1 occurs f1 times, x2 occurs f2 times, x3 occurs f3 times, x4 occurs f4 times, all the way up to x of n, which occurs f of n times. And so now basically the sum of all of those observations would naturally be x1 times f of 1. Then you would have basically x2 occurs 2 times, so x2 times f of 2, and x3 occurs f3 times, so x3 times f of 3, plus all the way up to x of n times f of n. That is the sum of all observations. That is the sum of all observations. Now, if I divide the sum of all observations by the number of times that they happen, basically that the total number of times that they happen, which is basically f of 1 plus f of 2 plus f of 3 all the way up to f of n, that is the same thing as what I've written over here. So that would be the mean of all observations. That would be the mean of all observations x1, x2, x3 all the way up to x of n, having frequencies basically f of 1, f of 2, f of 3 all the way up to f of n. Okay, and we denote this by x bar. That means that then x bar is x1, f1, x2, f2, x3, f3 all the way up to x of n, f of n, all divided by f1 plus f2 plus f3 all the way up to f of n. Now we can of course use the sigma notation in order to make things simpler, meaning that instead of this long formula, I can write x bar is equal to, instead of x1, f1, x2, f2, x3, f3 all added together, I can write sigma x of I, f of I, as I goes from 1 to n. So this notation here has the exact same meaning as this expression up here, and so then naturally the expression in the denominator, I can write it as sigma f of I as I goes from 1 to n, and that is the formula for the mean of of n observations having basically these frequencies. Okay, so that is that. So now let's apply this formula in at least one example, and then we will move to the next one. Okay, so now in order to basically use this formula in the context of some practical example, so what you have is the marks obtained by 30 students, marks obtained by 30 students of class 10, for example, of a certain school in mathematics paper, for example, in some subjects, or for example in mathematics paper, for example, consisting of 100 marks, are presented in this table. You want to find the mean of the marks obtained by the students. Find the mean of the marks obtained by the students. So basically you have, let's say that the marks obtained, let's call them, for example, the marks obtained, and then you have the number of students who got those marks, and then you have basically, and that's it basically. So for example, let's say that the mark was 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. So you have basically classified your marks like this. So the number of students who got those marks were, for example, so the number of these students who got those marks were respectively 11343, 11343, 244, 24411. Oh, there seems to be something wrong here. Actually, these are all wrong. I should have suspected this earlier, but I didn't. So the marks are actually basically 10, 20, 36. 10, 20, 36. This is much more realistic. 40. 50, 56, 60, 70, 72, 80, 88, 92, and 95. And the number of students who got those marks were 1134, 24411, 11343, 24411, 24411, 231. Okay. Now we said that now you want to find the average of, or the mean of, the marks obtained by the students. So we said that x bar, or the average of the marks, is equal to sigma x of f of I times x of I as I goes from 1 to n over sigma f of I as I goes from 1 to n. So what I need here, so this is the formula. So what I need here is sigma f of I x of I and sigma f of I. So sigma f of I x of I, what that means is that I'm multiplying f of I and x of I together, and then take basically then add all of those together. So now what is x of I, what is f of I here? X of I is each and every one of your observations is called an x of I. This is each and every one of your observations is called an x of I. And the frequency, the respective frequency of each observation is called f of I. It means that the frequency of x of I is equal to 10 was 1. The frequency of x of I is equal to 20 was 1. The frequency of x of I is equal to 36 was 3. And what that means is that, for example, x of I is equal to 36, or the mark 36 occurred 3 times, or basically in simpler language, was scored by 3 students in that class. So basically then naturally what I need to calculate is f of I times x of I, and then add all of those, basically all of those products together. So I write f of I times x of I here. Now f of I times x of I would be this column times this column, which would be 10. 20 here. 36 times 3 is equal to 108, I suppose, if I'm not mistaken. 3 times 30 is equal to 90, and that's 18, so 108. That's 160. That is 150. That is 100, that's a 12, so that's 112. That is 4 times 6 is 240. That is 280. That is 72. That is 80. And that is 160. 160, and that's 160, and so you have 160 plus 16 is 176. 176. 3 times 92 is 3 times 9 is equal to 270 and 276. And then lastly, you have 1 times 95 is 95. Now you need to add all of these together and call it sigma f of I times x of I as I goes from 1 to n. So I add all of these numbers together. And in order to do that, I can use, for example, some other page here. Let me use paint, for example. So I have 10 plus 20 is equal to 30. Then I have 108 and 160, which is 268. 268. 150 and 112 is equal to 262. 262. 240, 280 is equal to 400, and 500, this would be 520. 520. 72 plus 80 is 152. 176 and 276 is that's 300, that's 176 and 276 and 95, which is equal to 10 and here you have 12, 14, 19, so that's 29, so you have a 2 here, that's 11, 11 plus 6 is equal to 17, 19, 19, so you have a 19 there, and then you have 12, 12 plus 9 is 19, and 9, so that's 27, 2, and that's a 4, 47. You have a 4 here. So you have 8, 8 plus 5 is equal to 13, 15, and 17. 1779. 1779. So the all of these numbers added together would be 1779. Now one more thing that I need here is sigma f of I. So f of I was basically the frequency of all of those observations. So then sigma f of I, as I goes from 1 to n, is equal to 2 plus 3 is equal to 5, 9, 12, 14. 14 plus 8 is equal to 14 plus 8 is equal to 22, 24, 26, 29, and 30. That is 30. So that means that then basically x bar, or the mean of all those numbers, that means that then x bar, or the mean of all those numbers, is equal to sigma f of I x of I, as I goes from 1 to n, which is 1779. 1779 divided by sigma f of I as I goes from 1 to n, which is 30. Now if you do this, basically we can use a let's use a not a calculator. Okay, so 1779 divided by 30 is equal to 6 times 30 is equal to 180, 5 times 30 is equal to 150, and then 7, 2, 9, and 5, 6, 7, 8, 9. 9 times 3 is equal to 270. I have a 9 here. Point 0.00. 3 times 30 is equal to 90. That's 59.3 is the mean of all of your numbers. So 59.3 is the mean of all of your numbers. So that's basically, for example, how you use this formula in order to find the mean of basically some observations like this. Now the rest of the material that we have is basically in real life. In most of our real life situations, data is usually so large that make myself some coffee. Okay, so then we have in most of our real life situations, data is usually so large that to make a meaningful study, it needs to be condensed as group data. So we need to convert given ungrouped data into group data and devise some method to find its mean. So basically, so far what we have done is that the data that you can see here is ungrouped data, meaning that, for example, you have each individual, basically, observation appearing in a table, and then the frequency related to that observation, and then using this formula we can of course calculate the mean of all of those observations. But when the data gets, but basically when the number of your observations gets too large, then it's not possible to do this kind of thing anymore. I suppose that you have, for example, 50, 100, 150, 200 or even more distinct observations and their respective frequencies. Then your table would have something like, for example, 50, 100, 150 rows like this, and it would simply be impossible to basically to find the mean of that number using this formula, meaning that it would not simply be practical. So we need to basically, we have ungrouped data, and we need to convert it into group data so that we can work on it. And then once we convert it, like for example, the example that we had, like the class involves 10 to 20, for example 0 to 10 and 20 to 30 and so on and so forth. Once we have those groups and those class involves, or those classes in short, then we need to devise some ways in order to be able to work with the data in that format. So now let's see how we can do that. So for example, we had some example which is in this book has been called example number 1. Let's convert that ungrouped data into group data by, for example, some class intervals of width, for example 15. So let's see what example number 1 was and see. So example number 1 was for example this example here. So let me show you actually how you can, from the very beginning, convert basically ungrouped data into group data and do the whole thing. So this was example number 1. We had basically these were the marks obtained. These were the marks obtained, which has been called x of I, and these were the number of students who got those marks, and this you can call f of I, and then the marks were, for example, 10, 20, 36, 40, 50. The marks were 10, 20, 36, 40, 50, 56, 60, 70, 72, 80, 88, 92 and 95, and then the frequency, the respective frequencies of these are 1, 1, 3, 4, 3, 3, 4, 3, 2, 4, 4, 1, 1, 2, 4, 4, 1, 1, and 2, 3, 1. Okay, so this is an example of ungrouped data. This is ungrouped data. This you can call ungrouped data, right? Now, in order to group this data, so you can see that your basically the marks go from 10 all the way up to 95. So, meaning that 10, 20, 36, 40, and there are marks between 10 and 95 all over the place. So, and this is ungrouped data. You want to make some class intervals out of these marks, and convert your data into group data. So how can you do that? So what you can do is that you can define some class intervals. You can define some class intervals, and basically then the number of students. Now I'll tell you what I mean by this. So what I can do is that so if, for example, it depends on how you want to, basically how it's more convenient to I mean, the higher the width of the size of your class interval, basically the more information you will lose, the more detail you will lose. Meaning that if I make, for example, the width of my class interval, for example, from 10 to, for example, 95, I would have only one class interval, and then I would add all of these numbers together and write it over here as the frequency. So that would be just one class and basically all of these numbers as the frequency of that one single class. And then that way I will lose all of the numbers that basically all of the marks basically in that class interval. On the other hand, and you can understand that of course doing that, I would not have access to any of those particular marks. I would have access only to one single class, meaning that if I write, for example, 10 to 95, and then the frequency, whatever the sum of these numbers is, then there is no way for me to know if, for example, 40 was originally in my numbers or not, or if 70 was in my numbers or not. The only thing that I could say about this would be that basically there have been an X number of marks who have fallen within this category. For example, from 10 to 95. That's all I know about my data. Otherwise, I have lost all of the information about my data. Now, on the other hand, what I can do is that I can make the size of the class intervals smaller to accommodate all of this data in a rather convenient and also practical way. Meaning that, for example, I can make the size of the class interval 15, meaning I can start from 10 and adding 15 to that I'll get 25. And then again 25, add 15 to that, you'll get 40. 40, add 15 to that, you'll get 55. 55, you'll add 15 to that, you'll get 70. And 70, add 15 to that, you'll get 85. 85, add 15 to that, you'll get 100, right? So these are now the class intervals that I have defined. It's up to me what to do here. And then each of these numbers will fall within one of these class intervals. Now it's for example 10 will fall over here. So I have a 1 over, so I mean basically these tally marks, and then so for example I have one tally mark or a frequency of 1 here. Then 20 will also fall here, so plus 1. 36 will fall here, so 3 over here. And a 40 would fall here. A 40 would fall here basically. So it's important to note that, for example, when you have 40, this class interval does not allow 40. This class interval will fall 40, which starts from a 40 and goes all the way up to some other number. So 40 would be 4, for example. 50 would be 3, which is basically this thing over here. 56 would be 2, which is basically this thing over here. 60 would be 4, which is this thing over here. 70 would be 4, which is this thing over here. 72 would be this one, so 72 is 1. 80 would be 1. 80 would be 1. 88 would be 2. 92 would be 3. 95 would be 1. And then I can add all of these together. So I have basically a 2, a 3 here, I have a 7 here, I have a 6 here, I have a 6 here, and I have a 6 here, right? So now the frequencies of all of these class intervals I have written over here. So these are the class intervals and these are the number of students. So 2, 3, 7, 6, 6, 6. And the only thing that here you need to remember is that, for example, when you have a 40 and you have to put it in, you can put it in only one class. You can put this in only one class. You cannot put it in two classes. And this class goes from 25 to 40. This class goes from 40 to 55. So then I have to put my 40 over here and not over here, okay? Meaning that to the higher class, that this 40 belongs to the higher class and not to the lower class. And higher and lower here means that, for example, this class here relative to this class is higher, and this class relative to this class is lower. It doesn't depend on their rank, the way that they appear on paper. It's basically when you say 25 to 40 and 40 to 55, 40 to 55 is basically thought of as a higher class than 25 to 40. Okay. Now, so now basically we have all of these frequencies related to these class intervals. If I can call this, for example, f of I, and you saw that in that formula, what I had basically was that x bar is equal to, for example, sigma f of I times x of I, as I goes from 1 to n, over sigma f of I as I goes from 1 to n. So I need my sigma f of I, which I could calculate from here. But then I also need my sigma f of I x of I. But the problem is that now my x of I is lost, meaning that basically all the observations are now lost in these classes, and I have no x of I, practically no x of I. So now to get over this problem, what they have done is that they have basically defined some concept called the class march. They have defined something called the class mark, and the class mark is basically the average of each class interval, meaning the average of the lower limit and the upper limit of each class interval. So this number that you see here is called the lower limit of this class interval. This number over here is called the upper limit of this class interval. That does make sense, of course. The names are self-descriptive. Now, the average of these two numbers, if I calculate 10 plus 25 divided by 2, that would give me basically 35 divided by 2, which is something about 17.5, for example. So 17.5 is some number exactly between 10 and 25. And this way, what we are, and the way that we are going to use this number is that we are assuming that all of the numbers that fall within that fall within this class interval are somehow, meaning that we take this number as kind of a representative of all of the numbers that fall within this class interval. So you can see that it's important to, as far as it's possible physically, or basically as far as it's really possible, pick the kind of class intervals that are not that too large, because then this number, for example 17.5, would be representative of a large, basically large array, or a large, basically a large array of numbers, or a large basically, what do you call it, a large array of numbers, meaning that your number could go from, for example, 10 all the way to, for example, 25, and then right over here you have 17.5. Now any number that falls within this class, any number anywhere in this class that falls within this class, we take that number, what we are doing, we are actually taking that number as 17.5, and so that basically is going to basically diminish all the accuracy of all of your calculations once the value of this class mark, this number is called the class mark, once the value of the class mark is not very close to most of the actual values, right? So now, on the other hand, suppose that I take the class mark as, for example, I don't know, 10 to 15, for example. 10 to 15. And 10 to 15, that's 25, and then 25 divided by 2 is equal to 10 and 12.5, for example. Now, any number falling within this class category that goes from 10 to 15 is represented by 12.5. And now it doesn't really matter much, really. It doesn't really matter much what your number was that fell within this class category, because whatever that number was is very close to 12.5 as compared to, for example, to this case, which you can go all the way down to 10 and all the way up to 25. So you need to take that into consideration when you pick your class width, basically, or class size. The higher precision and accuracy that you want in your calculation, the lower has to be the size of your class. The lower has to be the size of your class intervals, basically. But of course, then at the same time, you would get more work to do, because you would have more classes to deal with to come to the final conclusion. So that is basically that. Now what you need to do is that you need to basically take the average of the lower limit and the upper limit of each of those class intervals and call it the class mark. So the class mark is basically the upper limit. The upper class limit, actually. Write this properly. So the class mark is basically the upper class limit plus the lower class limit. The lower class limit divided by 2, the average of that, right? So it's some sort of assumption that we make that the frequency of each of of each of class intervals is centered around the midpoint of that class interval. So the midpoint or the class mark of each class can be chosen to represent the observations falling in that class. Okay. Now recall that we find the midpoint of a class or its class mark by finding the average of its upper and lower limits. It makes sense that you find that the class mark, which is nothing but the midpoint of these two numbers. So you simply find the average of the two numbers, which is this number plus the other number divided by 2, which you can write as the upper class limit plus the lower class limit divided by 2, and that is your class mark. So then that's one more thing that we need to do. Now, what happens is that basically in the previous examples you saw that we had our x of i's, and of course our x of i's are in this very example, our x of i's basically are these numbers over here, right? And then we somehow in the process lost our x of i's, and then we got these class intervals. Now the class mark that we defined here is going to serve use. Okay, so now that we have talked about the class mark, what we need to do is that, of course, calculate the class mark, or basically the class mark or x of I. And so the class mark will practically becomes your x of I. And so of course then 10 plus 25 is equal to 35. 35 divided by 2 was 17.5. 25 plus 40 is 65, so that's 32.5. And you can see that the difference between 17 and 32 is 3 and let me see. So 40 plus 55 is 95. 95 divided by 2 is equal to 45. 95 divided by 2 is 45, and 2.5, so you have 47.5. 47.5. And then, for example, 55 plus 7 is 125. So that's 60 plus 2.5, that's 62.5. There is usually, you can usually find some common difference here, meaning that, for example, the difference between 32 and 17 is 3 and then 15. You see the difference between these two numbers is 15. Again, 8 plus 7 is 15, the difference between these two numbers. That means that the difference between these numbers is basically your class length or your class size. Basically here your class size is 15. 10 to 25 is 15, or 25 minus 10 is 15. And when you get the first number, then you don't have to basically do all of this calculation here. You can get the first number and add 15 to this, you'll get 32.5, add 15 to it, you'll get 47.5, 62.5, and so on and so forth. So for example, 62.5 plus 15 is basically 0, and then 7, and then 77, for example. I'm sorry, 77.5. 77.5. And of course, if you do the calculation directly here, you will get basically 155. 155 divided by 2, which is the same thing as 75 plus 2.5, which is equal to 77.5. The same thing. And then 77.5 plus 15 is equal to is 5, and then 12, 1, and then you have a 92.5, for example. 92.5. So there you have your x sub i's, or the class mark, and now you can calculate, since the formula was basically x bar was equal to basically sigma f of I x of I, or as I goes from 1 to n, over sigma f of I as I goes from 1 to n, then of course I need to calculate sigma f of I x of I. So f of I times x of I is equal to basically these two columns multiplied together, so you get 2 times 70 is equal to 34, 35, and 2 times 32.5 is 65. I'm sorry, this is 3 times. So 3 times 32, so 3 times 30 is equal to 90, 3 times 2 is equal to 6, and 3 times 0.5 is equal to 1.5. So that's 97.5, for example. 97.5. And then you have 7 times 47.5. So 7 times 40 is equal to 280. 280, that's 49, and then that's 3.5. So you'll get 0.5, and then over here you get 12, 1. So that's a 13, 1, that's 332.5. 332.5. And then you have 6 times 62.5 for you. So 6 times 6 is equal to 360. 6 times 2 is equal to 12, and 6 times 5 is equal to 6 times 0.5 is equal to 3. So that's a 5, that's a 7, 375. 6 times 77.5 is 420, and then 6 times 7 is equal to 42, and then 6 times 5, that's a 3, so you have 5, a 6, and a 4, 465. And then 6 times 92.5 is equal to 6 times 9 is equal to 54, 540. 6 times 2 is equal to 12, and then 6 times 5 is equal to 3, so that's 5, 5, and 5, 555. I'm not sure about this last number, let me check it with the calculator. So you have 6 times 92.5. Oops, sorry. 6 times 92.5, 555. And then you have all of the information that you need. So my computer is not okay. Now I need sigma f of I x of I. I need sigma f of I x of I as I goes from 1 to n, which is basically practically all of these numbers added together. So it's basically 35, 97.5, 332.5, 375, 465, and 555. And then here 5 is equal to 0, 1, 6 plus 7 is equal to 13, 15, 20, and 30. And you have a 3 over here. 6 plus 9 is equal to 15, 18, 18. 18 plus 7 is equal to 25, 25, 31, and 36. You have a 3 over here. 9 plus 4 is equal to 13 and 18. 1860. 1860. So now you basically, we said that x bar is equal to sigma f of I x of I, which is this value over here, 1860, divided by sigma f of I, which is this value over here, sigma f of I, as I goes from 1 to n, which is equal to 5, that's a 12. 12 plus 18 is equal to 30, right? So these zeros you can cancel out, and 100, 14, 1586 divided by 3, 186 divided by 3, 6 times 3 is equal to 18, and 2 times 3, that's 62. That's 62. Now let's now this method, by the way, seems to be called the direct method. This method seems to be called the direct method. And let me write it down here. This is called the direct method. Okay. Now, let's go back and see what sort of x bar we got when we didn't have class intervals, which was example number 1. So that was 59.3. So 59.3 was the actual value of the average of all of those numbers when we use the direct method, which is basically writing all of the data in the form of these classes and everything else. Then you see the difference is around the difference is 59, so that's 2.7. 2.7 is, I don't know how many percent of the original value. 62 times x percent is equal to 59.3. So I want to know basically, no, I'm sorry. I want to basically the difference of these two numbers is basically 2.7, right? 2.7. Now I want to know what is 2.7 is what percent of 62. So 62 times x percent is equal to 2.7. So then x, if I multiply by let me write x divided by 100 is equal to 2.7 divided by 62. And so if I multiply by 100, I get x is equal to 270 divided by 62, which is equal to 270 divided by 62, which is around 4%, 4.3, 4.4%. So the difference is basically 4.4% of, this is 4.4 approximately. So the difference of this number from the original value is 2.7, and 2.7 is 4.4% of the original value, which is 62. So that is how basically the value using the direct method is different from the original value. Now let's do another one of these. Of course, we need to do that in the next video. We have a couple of things to do in this chapter, so we will take care of them and we will move to the next chapter. I'll see you in the next video.